Welcome to Geometric Galaxy. Good morning students. Today we are going to study about number system operations on real numbers exercise 1.4 question number 1, 2 and 3. Before we start solving the exercise questions, we should recall the basic rules. When the addition, subtraction, multiplication, division operation is done on a rational and irrational number, the result is an irrational number. Another thing, when two irrational numbers are added, subtracted, multiplied or divided, the result may be rational or an irrational number. These two things you have to remember. Now let us start with solving problems from exercise 1.4. Now the first question of exercise 1.4 is classify the following numbers as rational or irrational. We have 5 subdivisions to solve. Let us see one by one. First subdivision is 2 minus root 5. I hope you all know that 2 is a rational number. Root 5 is an irrational number. So, rational minus irrational is an irrational number. Therefore, 2 minus root 5 is an irrational number. The second subdivision is 3 plus root 23 minus root 23. To answer this question, first we need to remove the brackets. Plus 23 and minus 23 will get cancelled and we are left out with 3. 3 is a rational number. Therefore, 3 plus root 23 minus root 23 is a rational number. Third subdivision, 2 root 7 by root 7. This question is very simple, students. We will just cancel root 7 in the numerator and the denominator. So our answer is 2. 2 is a rational number. Therefore, 2 root 7 by root 7 is a rational number. Fourth subdivision is 1 by root 2. 1 is a rational number. Root 2 is an irrational number. We know that rational divided by irrational is equal to irrational. Therefore, 1 by root 2 is an irrational number. Very simple. Our fifth subdivision is 2 pi. 2 is a rational number. Pi is an irrational number. We know that rational into irrational gives an irrational number. Therefore, 2 pi is an irrational number. Question number 2. Simplify the following expressions. Here we need to solve 4 subdivisions. Let us see one by one. The first subdivision is 3 plus root 3 into 2 plus root 2. We need to solve this problem by using distributive property. This is just like binomial multiplication in algebra. Let us consider 3 plus root 3 as first binomial and 2 plus root 2 as second binomial. Now take the first term of first binomial and multiply the second binomial. That is 3 into 2 plus root 2. Similarly, you take second term of first binomial and multiply the second binomial. That is root 3 into 2 plus root 2. Now using the distributive property, we will first multiply 3 with 2, then 3 with root 2. Next, by root 3 we have to multiply 2 first and next root 2. Let us see what happens next. 3 into 2 becomes 6. 3 into root 2 is 3 root 2. Root 3 into 2 is 2 root 3. Then root 3 into root 2 becomes root 6. Therefore, the final answer is 6 plus 3 root 2 plus 2 root 3 plus root 6. We cannot further simplify this. Next, let us see what is our second subdivision. 3 plus root 3 into 3 minus root 3. The question is very simple. We need to use the identity a minus b into a plus b is equal to a square minus b square. Here a takes the value of 3 and b takes the value root 3. a square is 3 square, b square is root 3 square, 3 square is 9 minus root 3 square is 3. So 9 minus 3 is equal to 6. Third subdivision is root 5 plus root 2 whole square. By seeing the question itself, you should come to the conclusion by what identity we should solve this question. The identity we can use here is a plus b whole square is equal to a square plus 2ab plus b square. Now a takes the value of root 5 and b takes the value root 2. If we substitute these values in the identity, we get root 5 square plus 2 root 5 root 2 plus root 2 square. So root 5 square is 5. 2 into root 5 into root 2 is 2 root 10 plus root 2 square is 2. Now if we simplify this, 5 plus 2 will become 7. The final answer is 7 plus 2 root 10. Fourth subdivision is root 5 minus root 2 into root 5 plus root 2. This is similar to our second subdivision. We need to use the identity a minus b into a plus b is equal to a square minus b square. Here a takes the value root 5 and b takes the value root 2. So in the place of a square you will write root 5 square, and in the place of b square you will write root 2 square. Root 5 into root 5 is 5. Root 2 into root 2 is 2. So 5 minus 2 is equal to 3. Question 2 is over. Now let us see what is question number 3. Recall, pi is defined as the ratio of the circumferences, say C, of a circle to its diameter, say D. That is, pi is equal to C by D. This means to contradict the fact that pi is irrational. How will you resolve this contradiction? In the question it is given that pi is equal to C by D. It means circumference divided by diameter. For any circle, if you divide the circumference of that circle with its diameter, you will get the value as pi. Therefore, pi is equal to C by D. But we all know that all irrational numbers cannot be written in the form of p by q. That is, we cannot write in a fraction form. But here pi value is written in the fraction form. That is C by D. This is the contradiction to our assumption that pi is irrational. Let us see how to resolve this contradiction. 22 by 7 is the approximate value of pi. It is not the exact value. The exact value is equal to 3.141592 etc., which is an non-terminating, non-recurring decimal. Therefore, pi is an irrational number. If we measure the circumference or the diameter with a scale, either the circumference or the diameter may be an irrational number, because when we measure it, we never obtain an exact value. We know that rational by irrational or irrational by rational is an irrational number. Therefore, pi is an irrational number. That's all in this video. In the next video, we will see question number 4 and 5 of same exercise 1.4 on operations on real numbers. Thank you. If you find Geometrix Galaxy helpful, consider subscribing to my channel. And please don't hesitate to recommend this channel to your friends. Thanks for watching.